Thank you. I hope everyone's having a great day. I'm pretty excited about the webinar today. I'm joined by one of my colleagues, Peter Levitt, who's part of our storage solution architecture team. And I'm a product manager in our AWS Boston office. I work on our AWS Storage Gateway service, and today we're going to talk about how to use AWS Storage Gateway to enable faster recoveries in cloud or on-prem using volume gateways, storage gateway volumes. So let's start out by setting some context. Everybody knows that in today's world, the last thing you can do as an IT admin is forget to back up your data. There's nothing worse than coming in on a Monday morning to realize a drive has failed or a computer has failed, or heaven forbid, you've had something like a fire within your data center and you've lost critical data. There's just no excuse for that. And I'm sure your management team don't want to hear that you don't have a backup of the specific piece of data that they needed. So what do we mean by backup and recovery? So let's define some terms. So here on the screen, you'll see a timeline. There's two really important terms in backup and recovery that we're going to cover. Firstly, there's a concept of a recovery point. Now, recovery points vary by storage device, by application, and really all a recovery point is the point at which you're saving off data that you can go back to. So in the world of traditional backup, that might be a backup, a tape maybe, that you send off-site, or a backup taken by your favorite backup application. In the world of more immediate storage, such as a disk, it may be checkpointing of the disk. So a point in time that you could go back, a snapshot of a volume, say. In the case of a disaster happening, your business runs after that recovery point is taken, and then a disaster happens. So there's potentially a period of data loss between the backup that you took, or the snapshot of the volume, and the point at which the disaster happens. Concrete example here is maybe you take nightly backups, you send those tapes off-site. If a disaster happens in your data center at noon the next day, you've potentially got 12 hours of data loss between the last recovery point, the backup that you took, and the disaster happening. Your business continued to run for those 12 hours, but data was potentially lost. Work that was done during that time period was potentially lost. After the disaster, there's then a period of time when your business is starting to get going again. Your application is starting to catch up. You're bringing things back online. This gets you to a point in time when your business is back running. We call that the recovery time. In this instance, because there was a disaster and your application went down, there's downtime here. Your business is not running at full speed until you get to that recovery point, that recovery time. So the terms that we give to those are the recovery point objective and the recovery time objective. These are really important terms to understand. They're the objective time that a business can handle for both data loss and restarting the business in the event of a failure. And collectively together, they span from the recovery point, the last good copy of your data that you can have access to, the time at which your business is running at full speed again. Now, there's a spectrum here of recovery point objectives and recovery time objectives, from hours to minutes to potentially even real time. And it's going to vary by the application that you're using. So for example, in traditional backup and restore scenarios, what I mentioned earlier, maybe you're taking a nightly backup. That has a long RPO RTO in the matter of hours. Potentially you could lose up to a day of data. Restoring that data could take a period of time depending on whether the data was off-sited and needs to be brought back on-site. On the other side of the spectrum, the right-hand side, you have real-time. There are certain applications where you can't tolerate any data loss. You can't tolerate any downtime to bring the application back online in the case of a failure. So there's a spectrum here that different applications, different use cases are going to require. There's no one-size-fits-all. Obviously, everybody would say, well, I want real-time restoration, but real-time restoration is going to come at a cost. So potentially a business is going to employ multiple strategies here for doing backup and restore based on the cost to the business of doing that restore and the value to the business of restoring within a timely manner with a narrow window of loss of any potential data. AWS has multiple solutions that fall into this space, and today we're going to look at where Storage Gateway fits on this RPO RTO spectrum. We have two particular flavors of Storage Gateway, types of Storage Gateway highlighted on this slide. Storage Gateway VTL, tape mode, not going to be the topic of this particular webinar, fits into the category of a backup and archive storage. So it provides tape emulation. If you're doing traditional backup and archive, you can target Storage Gateway as your storage appliance, and it will allow you to do RPO and RTO in the hours or minutes time frame. In the middle here, we talk about Storage Gateway Volume, which is what we're going to cover primarily in this webinar, which allows you to do RPOs and RTOs in the tens or minutes of time. So for applications that you need a lesser data loss and a much faster recovery. We're going to talk in detail about volume and give you a demo of a real-time failover of volume towards the end. So for those of you that haven't heard about Storage Gateway, here's sort of a slide of AWS storage services in general. I wanted to give you a feel for where it fits in. So in the middle here, we see our 3 core storage services, providing block, file, and object storage through EBS, EFS, and S3 Glacier. Storage Gateway provides a data movement or a data transfer tool into those services, specifically into EBS and into S3 and Glacier in today's offerings. Diving into Storage Gateway a little, Storage Gateway is, there are 2 main components to Storage Gateway. One is a VM that gives you access to the service, and the other is a set of services that run in cloud that provide access to the underlying storage services. So the VM provides access to file storage from applications that want to talk about storing files through NFS v3 or v4, provides access to volumes for applications that can connect over the iSCSI block storage protocol, and it provides access to tape storage through a virtual tape library emulation, which again is over iSCSI, which is more than just storage. It provides device emulation for a media changer and drives, everything that's necessary to do a drop-in replacement of a physical tape robot. The VM itself runs on VMware or Hyper-V in your on-premises environment. We also provide AMIs, Amazon Machine Images, for running inside EC2. Once connected to your account, the VM connects to the Storage Gateway backend services over HTTPS, so any data coming from your data center is secure and transfers over the internet nicely through firewalls and such. Those backend services provide that bridge into the core Amazon storage services of S3, EBS, and Glacier. As an AWS service, we're fully integrated with things like Amazon CloudTrail for audit and management of logging of API calls, to CloudWatch for metrics around what's going on with the service, to IAM for access, and to KMS for encryption. The VM provides 3 core capabilities. One is protocol conversion, so we convert from standard storage protocols to cloud storage protocols, enabling you to take applications that are not cloud aware or not cloud native and have them use cloud storage without really knowing. Secondly, we're providing some caching. So because the VM is deployed on premises in your data center, your applications want to be able to read and write data at local LAN speeds. So the VM provides a cache of the most recently accessed data local to your application and manages asynchronous upload and synchronous download from the cloud as necessary. The VM also provides a way of optimizing data transfer between your data center and AWS by doing things like byte range gets, compression, and other techniques to move data efficiently over potentially lossy wide area networks between your data center and the AWS region that your gateway is working in. On the back end, all of your data is stored in Amazon S3. And for the different gateway types, we provide a slightly different way of storing it. For files, we map files to objects, so you get native objects in S3 that you can manage using all of the S3 capabilities. For volumes, we provide a way of accessing those volumes as EBS snapshots. And for tape, we provide storage in S3 with the ability to archive your tape data off into Glacier for long-term cost-effective storage. Customers come to Storage Gateway for a variety of use cases. Because we have that native integration with S3, Glacier, and EBS, storage that you bring into AWS through Storage Gateway is usable across the entire AWS platform. Customers do a variety of things with other services such as Athena, EMR, EC2, obviously with EBS Snapshots, Lambda, CloudFront, and a variety of other services that are available inside AWS that are accessible to you, or your storage is accessible to because it's natively brought into the core AWS storage services. On the on-prem side, because we provide standard storage protocols for accessing the gateway, your non-cloud native or non-cloud aware applications very easily work with the service and without any modification. And they become effectively unaware that their storage is being backed into the cloud, stored into the cloud. Specifically today, we're going to talk about 3 use cases here that Storage Gateway can help you with, namely backup, disaster recovery, and archive. So let's look at the 3 gateway types in particular and how they could be used for backup and archive. We'll cover file and tape very quickly because we're going to go into volume in a little more depth later. So in this instance, I have a backup application on the left-hand side of the screen here, connected to a file gateway using NFS. As files are backed up or written to the file gateway, they're transferred up into S3. They can go into S3 standard or S3 IA, or you could write a lifecycle policy to move data from standard down to IA and then ultimately down to Glacier. If you were using Volume Gateway, you could connect your backup application to an iSCSI LUN, to a volume, a block device. In this instance, the gateway is talking to Storage Gateway backend services to store that data in S3. We allow you to take either ad hoc or scheduled snapshots of your volume, which are made available to you as EBS snaps. The third gateway mode, being Tape Gateway, provides a virtual tape library, a full emulation of a tape library. In this instance, the gateway is connected to the Storage Gateway backend services, and your data primarily goes into S3, or initially goes into S3. And then when your backup application decides to eject or export a tape, the equivalent of sending a tape offsite perhaps to an offsite storage vendor, we move that data down to Glacier for longer-term archival at that cost-effective Glacier price point. We did a webinar earlier going into Tape Gateway in more detail, so I'm not going to cover it more than this slide today. But as mentioned, it provides the ability to natively store your data as tapes, pretend, if you like, to your backup application that you have a new physical tape library on-prem. This instance is a virtual tape library, but all of your storage is stored in AWS. As far as your backup application is concerned, it sees a media changer, tape drives, and all of the things it would expect from a tape library. Tape Gateway is integrated with many of the leading backup vendors as listed on this slide. And by integrated, we mean that you can fully manage all of your backups in terms of archival and tape management in the library through your backup application. You don't need to interact with the service at all once it's set up. If you were using File Gateway for backup and recovery, again, File Gateway is providing this interesting one-to-one mapping of files to objects. So the files that you write to File Gateway appear as keys, objects in S3, where the key of the object maps to the name of the file in the file system. So the objects in S3 that are the files that you see on-prem can be natively managed by all of the S3 capabilities, things like lifecycle, cross-region replication, and versioning, for example. So the main topic today is to talk about how we can use Volume Gateway for backup and recovery. Really the best way of thinking about Volume Gateway is a cloud-backed volume, a volume block device that's really stored in Amazon that the gateway is providing you access to on-premises through iSCSI. The gateway surfaces that volume to you, and our backend gives you the ability to take snapshots and clones for performing some of these backup and recovery operations. Volume Gateway comes in 2 particular types. One is stored mode, and we'll cover that first, and then we'll cover cached mode next. In volume stored mode, you can think of having all of your volume stored on-prem being backed up to the cloud on a constant basis. This is really useful for applications where there is lots of random reads or writes, or the data set that's being actively used by your application is large. It's not predictable. And in this case, you want low latency access to all of that data, so you want it all to live on premises close to your application, where your application can read and write it without needing to fetch data from the cloud. Your volume that you have on-prem is always backed up in AWS, and again, available to you as EBS snapshots. In stored mode, you'll deploy local storage to store your data, to store your volumes, and an additional piece of storage, which we call an upload buffer, which manages transfer of your data, queuing data to be transferred up to the cloud, up to AWS. All of your data is stored in S3 at the S3 price point. The volume is fully readable and writable on premises via the gateway, via the iSCSI target that's exposed by the gateway, and always backed up into the cloud. Now, as I mentioned earlier, we're integrated with Amazon CloudWatch, and that's the best way for customers to gain visibility as to what the gateway is doing. So the kinds of CloudWatch metrics that the gateway emits are things like how much data is coming in from your application server or going out from your application server, being written or read to the volume on premises, how much data is being moved from the gateway up to AWS, how efficient your upload buffer is, how much data is waiting to be written, and how fresh the copy of the data in the cloud is. So again, you can identify what sort of recovery point objective, how much data is potentially at risk if the volume on premises was to be lost. In the case of a stored volume, the way that data gets written is that you write data to the local volume. You copy that data over into the upload buffer, so it's queued awaiting upload. So the application synchronously writes to the local volume. Asynchronously, we then upload the data, compress it, and try and move as little data over the wide area network as we can to commit it to the back end such that it's backed up in the cloud. So again, while data is in transit there's potential data at risk if your primary volume was to be lost. So your snapshot would only contain the data that has been uploaded. Read operations work the other way. Stored gateway, in that a read operation is always going to come from your local volume because all of the data is on premises. So here in this diagram, we're reading the green block. All the data is there, so I don't need to fetch anything from the cloud. So your application gets low latency access to all of your volume. Cached mode is the other type of volumes that we provide. Cached is a little different in that in cache, the full copy of the volume is stored on the cloud, but we keep just the hot data on premises. This is a really useful one for scenarios where you want to thin provision the amount of data, thin provision your storage on premises, and have a much larger volume of storage in the cloud that is manifested or surfaced to your applications. Very good for backup use cases. And again, we're going to use cached volumes later on in our demo. This mode, as far as the application is concerned, he sees a fully formed volume on premises that he accesses over iSCSI, and we cache just the frequently accessed blocks. We totally manage the cache for you based on read and write activity. All of your data is stored in the cloud, so it's all safe if the gateway is lost. So let's look at an example of how a write would work in this case. My data comes into the gateway. I put it in the cache initially. I then put it in the upload buffer, queuing it for upload, and I then upload the data to AWS. In this instance, again, we're using the same technique of compressing the data and queuing it for upload. So your writes would happen to the cache. Your application is synchronously writing to the cache, effectively. You can think of it like that, and then asynchronously uploading to AWS. So your application moves on once the data is stored in the cache. A read works a little differently to stored volumes in that when you read data, we're first going to look in that cache to see if we have the data. And obviously, if the data is in cache, we can serve it back up to your application. If there's no data in the cache for the piece of what was being written, we're going to have to read it from the cloud. So given that this was just recently read data, it's hot data, we expect your application will want to access it again. We store it in the cache and then serve it up to your application. A cache miss like this is entirely transparent to your application, other than it sees additional latency in accessing that block. But otherwise, your application just receives the data that it read. So let's look at how snapshots work for both stored and cached volumes. In this instance, the snapshots that you take from Volume Gateway are EBS snapshots. They're first-class EBS snapshots stored with the EBS service. They enable you to do point-in-time backups, and we allow you to have either scheduled snapshots of your volume or ad hoc snapshots of your volume. In this instance, the snapshot that you're getting is a snapshot of the volume on premises. So a really interesting way of backing up on-premises volumes into EBS. If we look at how a snapshot gets created in this instance, we have a volume on premises that is partially mirrored up to the cloud. So in this instance, that piece of data B would go up to the cloud when a snapshot is requested. And the snapshot that's taken would contain all of the volume as it was written up into the cloud, as it was stored in the cloud. If you write additional data, then take another snapshot, we create another EBS snapshot. In this instance, EBS snapshots are incremental. And so that second snap would contain A, B, and C, all three blocks, if you like, that were written to the volume. Both snaps are available to you, and you can use both snaps to create either an EBS volume or a storage gateway volume when you want to do your restore. In this instance, we can see yet another incremental snap. The volume keeps moving on. So in this mode, we have now 3 snaps and 1 volume. So there's a number of different ways of recovering data once you've used Storage Gateway to store data. And this slide sort of summarizes the 3 different ways or the 3 different points at which you can perform a recovery. Some instances, depending on what your failure was, you may just want to recover data to your primary data center. It may not be a disaster. It may not be that fire that we had in our first slide. It may just be that a user accidentally deleted a piece of data, or you had a hard drive failure on-prem and you just want to bring back some data to your primary data center. So you can do that either with snapshots or volume clones. And we'll talk about volume clones in a moment. Very similar to snapshots, but all within the gateway service. If your primary data center was lost for some reason and you wanted to fail over to a secondary data center, that's also possible with Storage Gateway. We provide access to your data. Again, all of that data is stored in the cloud. So as long as you have a data center that can get to that AWS region, you can pull that data back to a second data center. Or because the snapshots of these volumes are EBS snapshots, you can obviously do in-cloud restores. So a lot of our customers are favoring disaster recovery where their second site is an AWS region. So if you wanted to restore your data into AWS, you can do that also. This example, we have a storage gateway that's running in my data center, and it has a single volume on it, and that volume is stored up in the AWS Storage Gateway service. We have 3 snapshots taken from that volume at various points as the volume has been filled up. Maybe they're the last 3 days of backups. If I want to recover something from maybe yesterday's backup, snap 2 in this case, I can request the Storage Gateway to create a volume from snap 2. Here I get my volume in cloud. That then surfaces to me as a new iSCSI LUN that my application can access that contains the volume as of that snapshot. So maybe we're an example where a user still accidentally deleted the file. I can go back and find that file now in yesterday's snapshot. If I wanted to do that in cloud, I could equally take snap 3 and create an EBS volume from that snapshot and attach that volume directly to an EC2 instance. So I can do in-cloud recovery. We have a number of customers that use this as a way of doing very quick recoveries of data using EC2 as their restore location. Lastly, if we had a catastrophic failure maybe, or just a need to move that data to a different AWS region or a different data center, I can copy that snap over to another region, because again, these are just EBS snapshots. So I could copy that snap over to another region. And then again, the same restore scenarios apply there. If I had a gateway in that region or an EC2 instance in that region, I could create a volume from that snapshot, snap 1, 3 days ago, and access the volume at that point in time. So snapshots become very flexible in that you can restore them back to storage gateway volume or an EBS volume, and you can move them between regions if need be. Clones are something that are internal to Storage Gateway and provide a mechanism for you to do recovery on premises. With a clone, you don't have the long chain or the long stack of snapshots like you do. You just have access to the most recent recovery point from that volume. So clones are really useful for disasters when you need to get back the most recent version of that particular volume that you just lost during the disaster. So in this instance, we're always keeping that most recent copy. So if you wanted to do a test to say, if I was to lose my primary data center, what data would I get back? You can create a volume as a clone of another volume, and then restore that, and you'd see the copy of what you would get in the event of a disaster. Clones are internal to Storage Gateway, so they're really fast in terms of the ability to restore them back to a gateway. And as I say, a very good mechanism for doing disaster recovery failover testing without even needing to take an outage on your primary. You can clone a volume while that volume is still in active use, still being used by your application, and you get the point in time at which you requested the clone in terms of what that volume contained at that point in time. Again, you can keep creating volumes. You always get the latest version of the volume. In this instance, again, I can create another gateway that's connected to that same region. I can clone a volume to another gateway. Again, this is more of a disaster failover scenario where my primary gateway has been lost. Maybe it's in my primary data center, and I want to do a disaster recovery failover to a secondary data center, the bottom one on the left, and showing that I can get a copy of that volume at the last known good point in time and pull it into that other data center. So I'm going to hand over to Peter now to give you a demo of how AWS Storage Gateway volumes can be used to do cross-site failover.
Fantastic. So in this demo that we're about to do, we have an environment that consists of some infrastructure in San Francisco, which is acting as our primary location, and a disaster recovery location in Boston. And what we have is we have both an application server and a storage gateway in volume mode configured in San Francisco, where we're actively writing data. As you can see, that data gets written to US East 1, where that gateway is registered. And what we're going to do is we're going to simulate a failure state in that we'll kill both the application server and the gateway in San Francisco. And from there, we'll go to the AWS console and we'll create a clone using the storage gateway cloning mechanism, and we'll present that to Boston, where we'll see our data with a small amount of data loss from the point in time in which we failed in San Francisco. So as you can see here, this is my Windows server in San Francisco that we have the San Francisco desktop wallpaper on. And it's if I open Disk Manager here, you'll see that it has both a boot volume, so a C drive in the case of Windows, and a D drive. This is actually a volume gateway volume. So I'm actually connected to that via iSCSI. You'll see there I have an iSCSI target, and that is actually the D drive on this particular server, which is hosted on a volume gateway in the same location, same network. And you can see I'm actively writing data to this volume. I'll quickly show you what that looks like from the console's perspective. So here we have the AWS console. If I just go to Northern Virginia or US East 1, and I go to Storage Gateway, you'll actually see two storage gateways in this console. You'll see the San Francisco one that has one active volume. We'll take a look at the volume. You can see it, that's 100 gigabytes in capacity that was provisioned there, which maps directly to the size of the volume that we're writing to. So you can see this is the gateway volume that we're currently writing to in our primary San Francisco location. Now, currently in Boston, we've deployed a gateway and a Windows server there as well, but there's no volumes attached. It's really just a warm standby for disaster recovery. If you take a look quickly at the data that I'm writing, simulating an application, I've written about 3,000 images to this gateway volume from my Windows server in San Francisco. And what we're going to do next is we're actually going to kill both the gateway volume, the gateway, I should say, the data of the volume stored in US East 1, but we're going to kill the gateway and this Windows instance that we're on here, it's Windows Server. So I'm going to do that now. Okay, any moment now. And, there we go. So what I've effectively done there is I've simulated a failure by taking down the virtual machine running the gateway and the Windows Server itself. So this is simulating a real disaster, losing all my infrastructure in my San Francisco location. So next, I log on to my Boston location where I have a very similar server to the one I was running in San Francisco. The main difference being at this point in time, it only has a boot volume. It doesn't actually have my data volume attached to it. So what we're going to do is we're going to create a clone copy of the volume that we were presenting into San Francisco into our Boston location so that we can recover from this disaster in Boston. You'll see I'm already actually iSCSI connected to a warm standby gateway as well. You'll see the IP address of the gateway there. So what I'm going to do is I'm going to jump into the console now. I'm going to go into Storage Gateway, and I'm going to create a new volume in Boston from the original volume that was being presented to San Francisco. You can see at this point, from the console's perspective, my San Francisco gateway is no longer available because we killed it running that script from the San Francisco location. So what I'll do now is I'll create a volume, and I'm going to create it on the Boston gateway. I'm going to make it 100 gigabytes, just like the original volume, and I'm going to clone from the last recovery point. And you'll see it'll then give me a list of available volumes that I have within that region. Now, in this case, the only volume I have was the one that I was presenting to San Francisco. And I'm going to give my iSCSI target a name. And then from there, I click Create. And this task is near immediate, so it's not relative to the amount of data we were storing in the volume at all. Okay, so at this point, I should just be able to refresh my iSCSI target on that gateway. And you can see there's a new one called Recover. And let me just get this console window out of the way so we can see what happens. And I'll click Connect. And you can see there's a 100 gig volume. And this is the volume that was being presented to San Francisco prior, or a copy of the volume that was being presented to San Francisco prior to the failure. Okay, so now we can see the volume has been given a driver letter, and we can now open it up and take a look at the content. So if we scroll down, we'll just see the data that we were writing previously in San Francisco, and you'll see the majority of it has made it across. So there would be a small amount of data loss. Anything that was in sort of the upload buffer, it hadn't been flushed yet, is lost. But you can see we've still got approximately 3,000 images that have been transferred in this process. So what we've really done here is we've taken an operating system, an application running in San Francisco that was writing to the gateway, which stored its data in the storage gateway service in US East 1. We've taken out that primary location, and we've been able to really quickly, so a really fast recovery time, been able to present the volume as it was when that failure took place to our Boston server and then continue running business. So you can see it's a very fast recovery time and very little data loss. Okay, so that's it. That's it for the demo. Paul, I'll pass it back to you.
Well, thanks, Peter. That's really awesome. I love seeing that in action. And as you say, the speed of restore is kind of impressive. Certainly, we've tried to race it in the office and copy volumes, clone volumes, and it happens almost instantaneously. You can run it through our API as well if you don't have all the clicking, and it happens, as Peter says, nearly instantaneously. So a really nice way to use Storage Gateway to do volume recovery, volume backup, and volume recovery between locations within your same location or into the cloud. Thanks for everybody attending today. I hope this webinar was useful to you. If you want to learn more about Storage Gateway, URL's on the screen here, aws.amazon.com/storage gateway, and we'll take some questions now.